this video, we're going to learn to apply the Pythagorean theorem. Before we do, I'd like to review something from a past video and some information in your packet. Recall when we looked at this video, we determined that if we looked at one of these triangles, we knew that this had a length of 3 and this had a length of 4, and we wanted to know what the length of this side was. And we found that the area of this square was equal to the sum of the areas of these squares. So we found that 3 squared plus 4 squared equaled the area of this square, which was 25. Okay. We then realized that we wanted a number that when you multiply it by itself, you get 25, and we found that that number was 5. Okay. Now this directly relates to the Pythagorean theorem, which says if you have a right triangle, and all of this information is important and it's in your packet, that the sum of the lengths of the sides squared, which in this case would be 3 squared plus 4 squared, equals the square of what we call the hypotenuse, which in this case was 25. Okay, so for any right triangle, here's a generic one, we have legs of length A and B. Doesn't matter how you label A and B, as long as they're the legs, which are the two sides that form the right angle. And it equals the square of the hypotenuse, which we call C, which is the side that is opposite the right angle. So again, the hypotenuse is very different from these ones in terms of the formula. So this is the general result of the Pythagorean theorem and how it applied here. We found this length, this missing side, by squaring 3, squaring 4, and finding the result. And then we didn't call it this at the time, but we took the square root of 25 to get 5. Now we're going to use this to solve application problems, and we're going to use derivations of this formula. So if we're solving for the hypotenuse is going to equal the square root of the sum of the squares of the legs. Remember, this is exactly what we did in that picture. We took 3 squared, we added it to 4 squared, we got 25, then we took the square root, and this is the general formula. So find the unknown side of the triangle. So notice here, we're given the two legs, they're making up the right angle, and we're missing the hypotenuse C, which is opposite the right angle. So C is going to be the square root of 12 squared plus 7 squared. Okay, and I could have written 7 squared plus 12 squared. It doesn't matter which leg you call A and which leg you call B, as long as you're clear about C being the hypotenuse. Okay, so now the square root is of this entire quantity, so we have to find this quantity first. So that means we have to square 12, square 7, and add the results. So, okay, I'm going to find 12 times 12, and you can use the squared button on your calculator. And then I'm going to add 7 times 7. And I did that all in one step, so the calculator would follow the order of operations, and I get 193. So now I need to approximate the square root of 193 to the tens place. I'll use the calculator for that as well. You would hit the square root of 193. I'm just going to hit the square root button. And to the tens place, it is 13.9, so I'm going to round up. So C is approximately 13.9. So we found the length of this side is approximately 13.9, based on just the lengths of the legs and the fact that this is a right angle. Let's look at the next one. Okay. In this example, notice we're given one leg is missing, and we're given the hypotenuse, the side opposite the right angle. So the way we would adjust the Pythagorean theorem without using the algebra, so this has algebra already done for us, is a is equal to the square root. Well, we'd find the hypotenuse squared and subtract off the square of the other leg. So if you think of this in terms of this picture, if we want to find a squared, this piece right here, we could take c squared, this piece, subtract off this piece, that will give us a squared, then we take the square root. An equivalent formula, it really doesn't matter what you call a and b, but I just want to give you both, is if we were to call this b, we would take the hypotenuse squared, subtract off the other leg squared. These are really equivalent, so you don't need to remember them both separately. Just remember that a and b are interchangeable, c is not. So, since they called it a is equal to the square root, must start with the hypotenuse. The order matters in subtraction. So 17.3 squared minus 3.8 squared. Now I'm going to compute the value underneath the square root sign, which we sometimes call a radical sign. So 17.3 times 17.3 minus 3.8 times 3.8 gives us 284.85. 284.85. Notice that's still under the square root sign. Okay. Now we're going to take the square root of this value, or evaluate the square root, okay, which on my calculator is just that button. Rounding to the nearest tenths, the hundredths place is 7, so I'll round up to 16.9. So A is approximately 16.9. Okay. Also notice when we evaluated the square root, okay, the square root sign goes away. So this means find the square root of this number. Once you found it, you no longer need a square root sign. Also notice our units were in meters, so I'm going to put meters here. So this is approximately 16.9 meters. Now we're going to look at two application problems. In NBA basketball, the width of the free throw line is 12 feet. Okay, so I looked this up. This is the free throw line is 12 feet. A player stands at one corner of the free throw line, so player 1 is standing here, and wants to throw a pass to his open teammate across the lane and close to the basket. So he wants to throw the ball to this person. If his other teammate, player 3, which is right here, he's heavily guarded, so that's why he doesn't want to throw it to him, is directly down the lane from him, 16 feet, so fill this in. We're told this is 16 feet, this length from here to here. Okay. How far is his pass to his open teammate? So we want to find this distance right here. Okay. Fill in the diagram below and use it to help you solve the problem. So notice that there are some right triangles here. So we want to find this distance here. Okay. If we use this as our right triangle, so this is a right angle, okay, this is also a right angle, okay, and notice there's two right triangles, so this is a rectangle split in two. We can use either one because this is the hypotenuse of both. We're going to need to fill in some opposite information, so notice since this is a rectangle, that means this distance is also 12 feet, and this distance is also 16 feet. Okay. So I kind of like my right triangles. To me, that one looks upside down, even though it's not. It doesn't matter which way we put it. It's still a right triangle. But I'm going to use this one. So use this side, and we know this side. This is the hypotenuse. I'll fill that in, and that's what we need to find. So since we need to find the hypotenuse, we're going to use that, we'll call it C, equals the square root of a squared plus b squared? Well, it doesn't matter which is a and b, so I'll start with 12 squared plus 16 squared. Okay. Now I'm going to find this value on the calculator. 12 times 12 plus 16 times 16 is 400. So c equals the square root of 400. And I believe that's a perfect square. And I will hit the square root button, and we get 20. So c equals 20 feet. And it's exactly 20 feet since this was a perfect square. So our answer to this problem is player 1 will need to pass the ball 20 feet to player 2. Let's look at one more. Sarah is flying her kite and it gets stuck in a tree. So here's Sarah. This is representing the tree. That's where the kite is stuck. She knows the string on her kite is 17 feet long. So this length right here, no, it doesn't quite look like it in the picture. Oops, excuse me. This length is going to be 17 feet. Okay? And she is 6 feet from the tree. So this is her distance from the tree. Now we're asked, how long of a ladder in feet will she need to get her kite out of the tree? So this is the height of the tree. We need to find a ladder that's as high as this tree. Okay. So notice, here's our right angle. We know our hypotenuse is 17 feet. The tree height is one of the lengths. Okay. So we want to use, I'll call it A. Again, it doesn't matter if you call it A or B. A equals the square root of the hypotenuse squared minus the other leg squared. The hypotenuse is 17 feet, so 17 squared minus the other leg is 6 squared. Now we'll compute this on the calculator. 17 times 17 minus 6 times 6 gives us 253. I don't believe that's a perfect square. So now we're going to find the square root of 253, so we can approximate it. And we get about, it said to round to the nearest hundredth, which would be 15.9. I would round up to 0.91. So 15.91 is 15.91, and that's measured in feet. So the height of the tree is 15.91 feet. She may not need a ladder that tall, since she could probably reach up from the highest rung, but we'll just play along and say that she will need a ladder of 15.91 feet to get the kite out of the tree.